Okay, hello AP Chem students. This is going to be a short lecture on dealing with acid-base problems and how you would calculate the pH. One of the things that you really have to watch out for is you have to know what are the major species in the solution. So when you think about that, you have to ask yourself, really, is this a weak acid or is this a strong acid? So again, memorizing those 6 strong acids is essential. Identify then if it's an equilibrium reaction or if the reaction will essentially go to completion. If it is an equilibrium reaction, or I'm sorry, if it's a weak acid, that means you need to use Rice tables, and that will happen. You'll learn about that in the next lesson. But if it is a strong acid, we essentially say that that reaction goes to completion. HCl wants to completely dissociate. HCl is a strong acid. HCl will break up essentially into all hydrogen ions and all chloride ions. Then you react the major species until you're left with an equilibrium reaction. That really only pertains to if you're working with Rice tables. And then, of course, that's what the whole purpose is that you're usually asked for a pH or a hydrogen ion concentration. So solve for H, or if they're asking for pH, that's what you would be solving for. Okay, so as I said, this is a lecture about how to calculate the pH of a strong acid. Well, since a strong acid completely dissociates, and again, this would be the 6 that you memorize, hydrochloric acid is one of them. I wrote the equation here, as you can see. I wrote the equation without the water, so without the hydronium ion, just to simplify it. But clearly the water could be in the reactant, and you'd have H3O plus as a product, and that clearly is something that you would see like in the textbooks. Okay, so if they asked you to calculate a 1 molar hydrochloric acid solution and calculate that pH, if you had a 1 molar hydrochloric acid solution, what you would be doing is that since 1 molar hydrochloric acid will dissociate into 1 molar hydrogen ions and 1 molar chloride ions, then we know what the hydrogen ion concentration is. It's 1.0 molar. And you can just take the definition of pH is the negative log of the hydronium or the hydrogen ion concentration. So you're going to take then pH is equal to the negative log of 1.0, which would give you a pH of 0, which, remember, for pH, yay, you can celebrate. There's no units necessary for pH. You just give me a number, okay? Don't be alarmed. Yes, you can have pHs of 0, and that really is the tipping point. 1.0 molar would result in a pH of 0. Could you have concentrations higher than 1.0? Of course you can. Those pHs we never really do measure with a pH probe because we know that those solutions would have a high hydrogen ion concentration. Now, same reaction, hydrochloric acid dissociating, but you have a different concentration. You have a much lower concentration. You are asked to calculate the pH of a 1.0 times 10 to the negative 10th molar solution of hydrochloric acid. Okay? Now, here's where you have to think a little bit. Look at, I'm going to try circling it here. Look at this concentration right here, okay? 1 times 10 to the negative 10th. You know that that concentration is really low. And you must think, what are the major species that are controlling the pH? In this case, it's water. It's not the hydrochloric acid solution. The Kw, as we learned in our earlier lessons, is 1 times 10 to the negative 14th, which means that water on its own would be producing a hydrogen ion concentration of 1.0 times 10 to the negative 7th molar, which is much greater than that hydrochloric hydrochloric acid contribution of 1.0 times 10 to the negative 10th. Therefore, the pH is 7. So what I would recommend to you guys is that watch those concentrations, okay? When those concentrations, if you're looking at, first of all, I'm looking at this and saying, yep, HCl is a strong acid, but if that concentration is much lower than 1.0 times 10 to the negative 7, water is going to be the controlling species. All right, how about you guys try? Let's take a moment and consider a solution that is 2.0 times 10 to the negative 3 molar hydrochloric acid. All right, you should be thinking, what are the major species in solution? Write them down now. Well, what did you write down for your major species? Did you believe that it is hydrogen ion, chloride ion, and water? That's because HCl is a strong acid. It's going to completely dissociate. And also in the beaker, we know that it's not pure acid. They're aqueous solutions of acid, so water is a major component. Now I take a look at this concentration and I say, yep, that's a concentration of hydrogen ion that is going to be much greater than that of the hydrogen ion that would be coming from the water dissociation with its Kw value. So when I calculate this pH, let's see if I can do this, I'm just going to say pH is equal to the negative log of 2.0 times 10 to the negative 3. And what I get for a value would be a pH of 2.70. Did you get the same? All right, the next problem then, let's take a look at this one. What if I asked you guys to calculate the pH of a 1.5 times 10 to the negative 11th solution? You should calculate that now. I'll pause. Okay, did you calculate that? Was this a tough problem? You should be able to just tell me the pH just really off the top of your head without any calculation. And the reason that you should do that is that, yes, we have a strong acid, so you know that you're going to get complete dissociation of the hydrogen ion and the chloride ion. But look at this concentration. That's a concentration that's way lower than 1 times 10 to the negative 7. And therefore, water is going to be what is controlling this pH, and therefore the pH is 7. All right, the last slide that we're going to do today is how we would calculate the pH for bases. And when we think of bases, we know that there's strong and weak bases, and we basically can think of them the same way as we think of strong and weak acids. Okay, strong bases mean that they completely dissociate. And typically hydroxide ion is supplied to the solution. For example here, I have sodium hydroxide plus the sodium ion will dissociate into a sodium ion and a hydroxide ion. If I asked you guys to find the pH of a 5.02 times 10 to the negative 2 molar solution of NaOH, okay, I'm going to point out a couple things here. What you have to just kind of like tune into is that I'm asking you for a pH of a hydroxide ion concentration. Okay, so there's a bit of a trick to this. Okay, you just can't take the negative log of the sodium hydroxide because you won't, and think you're going to get a pH because you really won't get a pH. You will get something called a POH. Okay, so in this case, I am calculating a POH, and I know that sodium hydroxide is going to dissociate into 1 mole of sodium ions and 1 mole of hydroxide ions. So if I start out with 5.02 times 10 to the negative 2 molar sodium hydroxide, I have 5.02 times 10 to the negative 2 molar hydroxide ions. Look at that molar ratio. It's a 1-to-1 ratio, right? So if I take the pOH of that, which is the negative log of the hydroxide ion concentration, I end up with 1.300. And then to get the pH, you subtract from 14. And this would make sense. A pH we would expect for a base to be very high. The pH for this base is 12.70. Take a look at my significant digits. Remember those significant digit rules for pHs, okay? They're a little different than what you deal with just on a regular basis with concentrations and such. So make sure that you're aware of those. All right, now the question would be, the final question, is that what would we do if the solution was barium hydroxide? Okay, same concentration, but you have barium hydroxide. What would that pH be? Now, what I just want to alert you to is that remember that barium hydroxide, so let's see if I can write this here, will dissociate into barium ions, and barium has a +2 charge, that's a 2, plus 2 hydroxide ions. Okay, so now the hydroxide ion concentration, let's say it was the same. Let's say this is 5.02 times 10 to the -2. Now my hydroxide ion concentration is 2 times that amount. So you do have to know a little bit about formulas. This is why we have you memorize formulas, and you do have to know a little bit about dissociation to be able to get to the right concentrations here. All right, good luck and have a good day.